Well, good evening and welcome to Dome at Home, the Makeup Edition, substituting for the one that we canceled last week. Thank you for your patience and your ability to actually find us on sort of an off night for us, but thank you very much. I'm your host, Scott Young, planetarium astronomer at the Manitoba Museum in Winnipeg, Manitoba, Canada, Treaty 1 territory, and it is great to be back. My home life is getting to be a little bit more stable, and that's made things easier in terms of being able to plan for shows and things like that. I'm really looking forward to this show, and next week we have our second annual holiday special, which I'll tell you about in just a little while. Nice to see folks checking in on the chat. Just say hello and let us know where you're watching from and so on. Oh, hi, Phil and Fallon. Nice to see ya. And yeah, it's always nice for us to see our Dome at Home family say hello and things like that. And I do appreciate, and my wife appreciates also, the cards and words of support and things like that have come in from the Dome at Home folks. She's doing well, and so everything is going well. Thank you very much for that. Hi, Forest family. Nice to see you. All right. We are going to be covering, well, originally, this show was going to be last week, and it was going to highlight the then upcoming Martian eclipse, the occultation of Mars by the moon as the moon passes in front of Mars and hides it. Well, that actually happened last night, and some of you were with us for the live broadcast. We had beautifully clear and bitterly cold skies, and it was quite a challenge for the equipment. That's something I wasn't quite, like I know that sometimes you're out in the cold, and if you have to be out there, got to take your gloves off to focus the telescope or to move things around or whatever. You just can't have all your winter gear on. And the observer gets cold. But I was really surprised at how much my gear got cold. The focuser stopped moving, and that made it difficult. So it did dip down to around minus 32 or so. So I guess I can understand it. Oh, hey Stan, nice to see you. You guys out in North Kildonan, thanks for joining us. So obviously we can't just run the show that we had prepared for last week because it's all old news. But we will talk a little bit about the occultation that occurred. We got some great viewer images that I'd like to share with you. And we're going to sort of expand upon that idea. You know, an occultation, a lot of people hadn't heard that term before last night. We're more familiar with the term eclipse. But an occultation is kind of a bit of an arcane kind of term for a lot of people. What are these things, and what good are they? Like, other than just being interesting to watch, what's the value of these observations? So we're going to talk about that. We're going to talk about the winter sky, and we're going to talk about the upcoming events between now and the end of the year. But first, we're going to start off with
cool space stuff.
So the Artemis mission is just way too cool to not talk about it right away. The rocket launched back, we watched it live here with the show, and the spacecraft has been performing flawlessly all the way there. The Orion spacecraft went out to the moon, looped all the way around it, did what was called a distant retrograde orbit, reached as far as any human-rated spacecraft ever has, although that'll be more impressive when there's actually humans on the spacecraft in a couple of years. But still, was kind of a milestone there, and took some great pictures of the Earth and Moon, because finally NASA realized it's a good idea to put pretty picture cameras on your spacecraft. Yes, they take extra weight. Yes, they have no value scientifically and no value from an engineering point of view, but we love them. And I got to say, this is probably the best set of pretty pictures that we've been getting from this particular mission. So swinging past the moon at high speed, but at very close distances, some great high resolution pictures. These are just spectacular. Now, if you were with us last night, you remember what the moon looked like through my telescope. The scale of that image is not all that different from the scale of this image, but I was looking through 200 kilometers of wavy air and things like that, and the Orion spacecraft was a whole lot closer with no air in between. So look how sharp these pictures are. And there are dozens of these all over NASA. NASA's website. So you can just look at them, and it's just amazing, the detail of some of these images. I see that I'm not quite, there we go, that's better. And they broadcast live the loop around the moon and the firing of the engine and the coming back. You could actually have watched the Earth rise and the Earth set as the spacecraft orbits the moon live on NASA TV. That's kind of a first for us. Really, really cool. So hopefully that kind of public outreach will continue. There's our little crescent Earth off in the distance there with the moon up front and the side of the Orion spacecraft on the left. Just some fantastic images. And definitely, if you get a chance, get onto the website and take a look at some of these on a good monitor where you can zoom in and really get a detailed look, because there's so much resolution on some of these pictures. It's just spectacular stuff. All right. What's coming up? This is the whole point of this test. The number one objective of the test flight has not been accomplished yet because it is testing the heat shield on re-entry. The heat shield, of course, is the thing that prevents the spacecraft from burning up like a meteor when it comes streaking back to Earth at 28,000 miles an hour, much faster than a spacecraft that's just coming from, say, the International Space Station or low Earth orbit. We think that the science and the engineering is known well enough to have designed this thing, but there's always some uncertainty. And so the test of this heat shield is critical to them putting people on the next flight on Artemis 2. So we're really looking forward to that. And the only way to test that is literally to see if the spacecraft burns up or not. So hopefully that won't be happening. It's on its way back to Earth now. It arrives on Sunday. And a little bit later, I'll show you the times for the splashdown party. NASA is going to be covering the thing live, of course. And there are a few splashdown parties around the country. Unfortunately, not one here in Winnipeg. It's difficult to have a splashdown party in the kind of temperatures that we've been having. So we will be watching online rather than being, out on a beach splashing in the water or anything like that. All right. I'd like to get to our What's Up in the Sky segment. We're going to talk about the winter constellations, the December sky. The great thing about December is that when the sky is clear, it is usually very clear, and it's dark at 4 o'clock. I know a lot of people are upset about that. I love it. You can get home, set up the telescope before dinner. Right after dinner, you get outside and you're observing in nice dark skies. I love this time of the year, except for the cold. But when it's clear, it tends to be really cold in December. So you have to dress warmly. You have to make sure you're wearing layers. Astronomy is not an aerobic activity, so you're not going to be generating a lot of heat yourself. You really need to depend on multiple layers of clothing to prevent you from getting frostbite. And in fact, I did wind up burning my thumb on I guess you can't see, on the telescope focuser last night when I went outside. Everything had gotten just so cold, and I had to touch it with exposed skin, and I've got a frostbite burn on my thumb from adjusting the gear. So, like I say, you have to be ready for that cold. But if you can get out there, the sky is beautiful. We've still got Jupiter as our highlight in the early evening. It's basically due south right about now. And it's in a fairly dim part of the sky. These other constellations here, we've got Aquarius and Capricorn and Cetus and Pisces. They're all made of fairly faint stars, so Jupiter really jumps out. It is down below the square of Pegasus, which is, we sort of think of Pegasus as kind of a fall constellation, but it's so big it actually stretches into the winter sky. Jupiter is, I would say, the highlight of the early evening, but not far behind is the planet Mars. Mars is rising as the sky gets dark, and by 7 or 8 o'clock, it is nice and high up, and it's almost as bright as Jupiter. Plus, it's got that red color. So you've really got a couple of nice bright objects to spot. Those are bright enough to see even from downtown with the lights and things like that. They're just so bright they will cut through. Tonight, the moon has moved on from its position. Last night, it was right over top of Mars, of course, but tonight it'll be over here, and each night it will move farther and farther to the left, essentially, relative to all the stars. But we have our winter constellations that we're kind of familiar with. Mars is in the constellation of Taurus the Bull, with the V shape of the Hyades star cluster right here. The bright red star Aldebaran, looking quite pale next to Mars, but when it's by itself, it's actually quite a bright and orange-colored star. That's the eye of Taurus the Bull, and this is sort of its head. And then it's got two long horns. It's like a Texas longhorn. Any of our Texas viewers out there today? We don't have the same kind of longhorns here, I don't think. Anyway, but this bull has really long horns that stretch up to here. And then in the bull's shoulder over here, we've got the beautiful Pleiades star cluster. That is one of the highlights of the winter sky, visible to the unaided eye, beautiful and perhaps best seen in binoculars. In a telescope, there's just so many stars. It's difficult to sort of appreciate quite as well as you can in binoculars or a low-power telescope. If you are using binoculars, over in neighboring Auriga, this constellation here, this is a charioteer, but it looks more like the Pentagon to me. There we have a bunch of little star clusters scattered inside this pentagon and along the outside edge here. They're much, much fainter and much, much smaller farther away than the Pleiades. But if you've got binoculars, and particularly if you got some of those larger binoculars, the 15 by 70s or the 80 millimeter binoculars, you'll spot all sorts of wonderful star clusters in and around this region. At least when the moon's not there. When the moon is right next to it, it kind of washes out a lot of the effect. Just rising in the east in the early evening, we've got Gemini, the twins, with the two twin stars. Castor is the top one, and Pollux is the bottom one here. And they're stick figures, the two brothers of Greek mythology. Right down at the bottom of the feet of Gemini, there's another beautiful star cluster right in and about there. This is sort of star cluster time of the year, because we're facing towards the part of the Milky Way, the spiral arm of the Milky Way, where there are lots of these relatively young clusters of stars spread around. And then, of course, rising is Orion. Let's take a look. Phil has asked, is NOS 4A an asteroid? No. That's a satellite. I forgot to turn off the satellite feature of Stellarium. I usually have that on when I'm running the telescope so that in case something comes zooming through the field of view, I know what it was. But you can basically download all of the satellites and it'll tell you, when the space station's up and whatever other satellites are out there. There are thousands of them, of course. Asteroids, much, much fainter, and they tend to not move the same speed as satellites. Satellites are just, relatively close. Good question. Thanks for catching that too. Orion is just rising. I'm going to just get to the point where we can just get a little higher in the evening, just so we can get a good look at Orion. Probably my favorite constellation. It actually kind of looks like what it's named after, a big, broad-shouldered, narrow-waisted guy with a belt of 3 stars. You won't find 3 stars that are this bright and this close together anywhere else in the sky. So it really does stand out. And then the 2 legs sort of come down here. Depending on the mythology you're using, he either has a shield or a bow and arrow in one arm, and the other arm is holding either a club or perhaps holding up an arrow or something like that. Hanging from Orion's belt is a little group of stars that marks his sword, and the middle one of those is a little bit fuzzy when you look at it in the sky, and the reason for that is it is what we call, I didn't turn on the picture there, what we call the Orion Nebula. And we've talked about the Orion Nebula before, a beautiful cloud of gas. You don't see these colors with your unaided eye, but it is a wonderful object to look at in binoculars or a telescope or anything really. Down below Orion and to the side, we're sort of still in that fairly dim area of the sky I mentioned with Jupiter. We've got Cetus, the sea monster here. This group of meandering stars is called Eridanus, the river. It's just, kind of a meandering line of stars. This one down here, which does get a little bit higher as the night goes on, will in fact jump forward just a little bit more even. So here we are around midnight, Orion standing high in the south. This is Lepus the hare. And it kind of, to me, it looks like one of those deer heads that gets mounted on the wall. You know, you've got like here's the sort of face, and there's the antlers, and there's the sort of neck part, and there's the part that it's hanging on the wall from. But Lepus the hare is actually a nice little constellation to find, and not too many people are familiar with that one. So you can go check out that one. And then as the rest of the winter stars come up, we've got the brightest star in the nighttime sky, Sirius, often called the dog star because it's part of Canis Major, the big dog, this constellation here. Sirius is so bright that, with the exception of the planets, it outshines everything else in the sky. You know, the planets, the sun and the moon, of course, excepted. It's bright enough that when it twinkles, you can actually see different colors flashing in its twinkling. Most stars, when they twinkle, we just sort of see the white color of the star flashing and sort of moving around a little bit and getting brighter and fainter and so on. But we don't see any color because the star is not bright enough to trigger the color receptors in our eyes. But Sirius is bright enough. And so as Sirius comes up, we always get lots of calls down at the planetarium saying, hey, there's this light in the sky and it's flashing red and green. What is that? I know it's Sirius, but I have to ask a few questions just to make sure that they didn't see, you know, something else. But that's a very, very common sighting, especially when it's just rising, because that's when you're looking through all of the heat waves in the atmosphere, all of the turbulence and things like that. And it's really made a beautiful sighting for a lot of people, but they don't know what it is. And so for them, it's a UFO. Okay. Fallon's asking how I keep the gel in my Star Blast from freezing. So the Star Blast telescope is a great little scope. Do you mean like the focuser grease? Or I'm not sure quite what you mean by the gel. Basically everything will freeze. And so, you know, when you get your telescope out into the cold, eventually it will reach ambient temperature. So it gets to whatever the air temperature is. It doesn't worry about wind chill. So, you know, minus 30 feels like minus 37, still is only minus 30 for the telescope, but that's enough for any parts that have grease on it, like motors or focusing knobs or any moving parts, to really get quite stiff. There's really no way to prevent it. So for winter observing, what I tend to do is to put in my favorite eyepiece as soon as I go outside, point the telescope quickly at the moon or a planet or any star really, just so you can focus it and then leave it there. And it'll sort of freeze in place, but it'll be in the right place. And so you can at least use your telescope that whole time. Now, as soon as you change eyepieces, you might have to move the focuser. I do know people that, I do know people that take out like a hair dryer to warm it up or something like that. You could do that. Or, any kind of, those hot packs you're supposed to put in your gloves. You could use something like that. I've never bothered. I just accept the fact that, changing eyepieces is going to be more hassle than it's worth when it's really, really cold. And I just focus it and leave it alone, basically. Todd points out that Lepus looks like Gary the snail from SpongeBob. Nice. I am totally stealing that. And in fact, I'm going to get one of my artist friends to make me a little SpongeBob, Gary the snail constellation figure that we'll use in the planetarium. That's a great idea. Okay. There's one more dog up in the sky that we'll talk about. We've got the Canis Major, the big dog, and Sirius. And then up here, we have Canis Minor. It's made of 2 stars. How is that a dog? Come on, ancient Greeks and ancient Romans. Put a bit more effort in, please. No, I mean, obviously you can't just add stars to make pictures. So in some cases, I guess the story was that Orion had 2 hunting dogs that accompanied him. And so when they were making these constellations, he needed to have 2 dogs up in the sky. And so these were the stars that left. This star Procyon is quite a bright one. So it really stands out. And then there's one here and a couple of other fainter ones, but it really doesn't form any kind of picture of a dog. Still, Procyon and Sirius down here form a perfect equilateral triangle with the shoulder of Orion, Betelgeuse. And even in the city, that triangle really stands out because it is sort of like a perfect equilateral triangle with all the angles equal, and all three stars are nice and bright. So that's a useful guide for the winter sky. Way over in the north, we're seeing the same constellations we always do: the Big Dipper, the Little Dipper, Draco, Cassiopeia, and Cepheus, and things like that. Cassiopeia is just coming down from the zenith, the point directly above us, and as the night goes on, it'll get lower and lower, but it's pretty high in the sky, and the Big Dipper is pretty low in the sky to start the evening, and by about midnight it started to stand up on its handle here. So again, those constellations still visible all year round, just their orientation has changed. There are a couple of planets we didn't talk about, and that was kind of on purpose, just because they're kind of past their prime. Saturn is still up in the sky. If you go out nice and early off towards the west, you'll see Saturn. It looks just like a moderately bright star, and it's down fairly low in the southwest already. Towards the middle of the month, though, Venus is going to pop up in the evening sky. Very, very low, and it'll take a while before we get a good view of it, but you might start to notice Venus, and also Mercury will make an appearance in the evening sky starting about the second week of December. So lots of cool stuff happening planet-wise, and we'll talk about a few more events as we go on through the show. Okay, let me just get this set. So last night we had the occultation of Mars. And if you were with us and you watched it live, it was very turbulent. This is the view through the telescope, and you can just see Mars popping out there. This is the reappearance. I managed to hit record for the reappearance. I was too busy trying to make things work for the disappearance. But it was amazing how fast the moon moves relative to the much more distant Mars. We'll watch that again, and it really opened the distance quite amazingly fast. Like, this is real time, so this is basically just a few seconds, and Mars was visible and out there. And only a few minutes later, Mars was already easily visible to the unaided eye, far away from the planet. I asked, and you delivered. There are some great shots that came in for the occultation here. Here's one by Ulrika, who was alternating between watching the broadcast, watching it live with the binoculars, and taking pictures. So congratulations on juggling things as I was. This is a great shot of the pre-stages. And this is you'll notice that these images are challenging to make well, because you want to take a long exposure so that you can see Mars, which is quite faint compared to the moon. But if you take too long of an exposure, you won't see any detail at all on the moon. It'll just be overexposed. So this was a really nice balance here, being able to show still the face of the man in the moon, and the little planet Mars off to the side there. Nice job, Ulrika. Andy sent this one in as well. This is a shot just looks like maybe 10 minutes later, and Mars is getting really, really close to the thing here. Nice job on preserving the detail of the moon as well. And you can sort of see a little hint of the red in the Mars there. It's not quite as striking, and I was surprised in my images. It also was not as bright striking as I thought it would be. It almost looked less red than it does when the moon wasn't there. I'm not quite sure what was going on there, and Dale and James also had a shot here. This actually, they sent in quite a few great shots. This is after reappearance, and you've got Mars coming out the other side here, and there was like a nice series of all of them. I was trying to put them all together into a nice little animation, but I didn't get it done in time for the show. But I'll still do that, Dale and James, so that you can sort of see the stop action of your nice series of images. Great job on capturing this. Okay, and so when this happened, a lot of people heard the word occultation for the first time, and certainly a lot of the media heard occultation for the first time. And because the root of occultation is the word occult, which means hidden in Latin, but has taken on sort of a magical significance in today's world. People are like, oh, this is an occult event. And there were all sorts of interesting commentary out there about the significance of this event. We in the astronomy club, we had a fellow speak at the November meeting. He's Roger Venable is the director of the Mars section of the Association of Lunar and Planetary Observers, which is basically a big group of people that like looking at the planets. And he told us about this event, of course, and he said there's absolutely no scientific value in observing this event, but it's going to be cool. And he was totally right. But we have better ways of learning about the moon and learning about Mars than by observing them in this sort of indirect way. I mean, there is information that you can calculate, for example, how fast the moon is moving relative to the background of Mars, and you can calculate how big Mars is relative to the moon and therefore work out its distance and stuff like that. But we already know that stuff, so why would you? It really doesn't have the scientific value. It's just a really cool thing to watch. But when other objects are involved, an occultation can actually be not only scientifically valuable, but it can be the only scientific way to learn about particular objects. For example, imagine an asteroid. An asteroid maybe 10 kilometers across. That's pretty small, and it's out there in the orbits between Mars and Jupiter. We could see that in our telescopes from Earth as a dot. You couldn't resolve it to see what shape it is or what color it is or anything like that. It's just so small and so far away, all we can do is see it as a dot. If we want to know anything about that asteroid, we basically have to either fly a space mission there, so build a robot, launch it for several years, mega expensive kind of project. Or we have to wait until it just happens to pass in front of a distant star. It will occult a distant star. And there's lots of stars out there, and there's lots of asteroids out there. So these asteroid occultations actually happen fairly often. And in fact, there's one coming up in about 11 hours that crosses Winnipeg. I'll flip over to the thing here. So when an asteroid, these tiny things, occult a star, there's basically a shadow cast on the Earth. And it's a very small shadow because the asteroid is very small. Sometimes it's only a few kilometers across. And as the asteroid moves, that shadow sort of sweeps across the globe. Well, the one that's happening tomorrow basically sweeps across the continent from New York up through southern Ontario, right over top of Winnipeg, and then off to just north of Saskatoon and north of Edmonton, and then off through northern BC before going off into the ocean. If you were to watch that star, you wouldn't be able to see the asteroid beside it as it's coming close because the asteroid is so small and faint, it's invisible. But the star is actually pretty bright. Just by coincidence, the one that is happening is one that you could probably see in almost any small telescope, maybe even in big binoculars. When the asteroid goes in front of it, the star appears to disappear. The star disappears for a few seconds and then comes back. If you timed exactly how long the star disappeared, you'd actually be measuring the size of the shadow of the asteroid. And if you had a bunch of people all over the world who were all measuring the shadow in different places, because, as the path goes across, someone might be right in the middle of the path, somebody might be sort of on the north part of the path or the south part of the path. When you stack all of those observations together, and if they're timed very, very precisely, you wind up with a graph that sort of gives you something like this. These dotted lines, each one represents a single person watching a star and basically timing when the star disappears and then when it reappears. And in between, there must have been asteroid blocking out the star. You get enough people, you make a map of the asteroid. Even though the asteroid is far too small for us to ever resolve in a telescope or to see it any other way, you can actually map it. And in this case, they discovered that the asteroid was actually two asteroids, a binary asteroid. Sometimes asteroids have moons, and many of those have been discovered by watching these asteroid occultations. Now, it's a fairly involved procedure. You have to have your exact position, and you have to have a way of recording the observation and having very precise time, whether it's a shortwave radio that has time signals or a video camera that has time signals or something like that. It takes a little bit, but it's surprisingly easy to do. And it literally can have you discover an asteroid moon or something like that. So these occultations, while the one last night was just a pretty thing, are cutting edge science in a lot of ways, which is kind of cool. Here's another kind of occultation that up until recently we didn't know about. All the stars out there, a bunch of them have planets. And if we're lucky enough that the planets go around kind of in our line of sight, then the tiny little planet will occult the star when it passes in front of it. And that'll make the star get slightly dimmer. And it will stay dim for a little while, and then it will get slightly brighter as the planet moves off. Those occultations help us discover planets around other stars. That's how we first discovered planets going around other stars. Now there are spacecraft that do nothing but look at stars constantly to see if there are occultations happening, to see if there are planets there. So those of you that watch the Mars occultation, you're basically doing the same process that some of the cutting edge astronomers are doing, and you're doing it from your backyard just for fun. So good on you. It's kind of interesting how you can take something that seems like a casual observation, and with just a little bit of additional effort, it actually turns into valuable science, because there's a lot of universe out there and not enough astronomers to study everything. So folks like you and me, we pick up some of the slack by doing some of these science things. Okay, Ben says, kind of like the square kilometer array. Okay, I see what you mean. So the square kilometer array is a big radio telescope that basically has a bunch of little radio telescopes that's sort of all combined to give a larger picture, as if it was from a larger telescope. So yeah, it's kind of the reverse of that, essentially, I guess. Whereas here we're sort of looking at trying to resolve the little objects with our timing of the brightness of the star. All right, let's see here. We had a couple of other things I wanted to get to, and let's just see events that are coming up. I did want to let you know that the planetarium is going to be open for our winter break, and of course is open right now. There's a new show for the kids opening on winter break. It's called Beyond the Sun. Opens on sort of the Christmas weekend, I guess, and goes all through the winter break. And it is all about planets around other stars. So that's a fun show. It actually stars the same characters as our dinosaur show from last summer. So it's a nice fun show. And so that's running. And we have some other events going on as well. Oops, there we go. Orion splashes down on Sunday. We're not doing a live broadcast because, for a variety of reasons, but the coverage on NASA TV begins at 10 in the morning. Splashdown is at 11:40 Manitoba time. So that is basically the way that we can watch that. I'm going to try and get on and watch as well, but Sunday's a busy day around here, so we'll have to see how that goes. The next couple of days, we've got the Geminid meteor shower. Geminids are the best meteor shower of the year. The peak is late Tuesday night into Wednesday morning. We're going to start broadcasting at 8 o'clock on Tuesday, and we'll see how long it goes. If the activity is good, we'll stay on longer. But that's something we've been doing for a few years now, and it's always nice to just basically have the all-sky camera set up. We can just watch the meteors as they come in, and just usually it turns into sort of an Ask Me Anything kind of thing. People are asking questions about this, that, and the other thing. But that's a lot of fun. If the weather is not ridiculous, I think I'll probably observe this from Birds Hill Park. And so if folks are interested in joining, you can always drop me a line through the links that we will give you right now. You can get us through Facebook and YouTube, and of course space@manitobamuseum.ca. Let me know and we'll try and coordinate just to make sure that people all wind up at the same place. But definitely Birds Hill Park is trending to be my go-to observing spot for these live events. The night after, we have a concert in the planetarium. This is kind of a cool thing. There's a brass quintet of musicians from the Winnipeg Symphony Orchestra that have put together a nice, basically holiday concert and sort of winter themes and things like that. And my colleague Adriana, who will be doing all sorts of magical stuff visually using the Digistar system to sort of go along with the music. So that's a lot of fun. Tickets are available through our website. And I love it when we do musical things and stuff like that in the planetarium. It is a theater after all, and it's nice to use it for all sorts of different kinds of performance. And then the night after that, we have our final Dome at Home of the year, which has, last year we did a sort of a holiday party where people came on and just chatted. What we're going to do this year is you can watch the show the way you normally do and participate through the chat the way you normally do. Or if you want, you will be able to sign in through Zoom, and you'll be able to, we'll basically sort of go around the room and people can say hello, talk a little bit about, what you did, what was your favorite observing for the year, or what you're looking forward to next year, what kind of observing you're doing and stuff like that. It's a way for us to sort of just socialize and get to know the other members of the Dome at Home family. And it's still hard. I haven't figured out a way to share virtual baked goods, but that'd be the only thing missing from our holiday show. So the event for that is already up on the Facebook page at the Manitoba Museum. And as soon as I get the Zoom link set up, I will post that there as well. And folks are welcome to sign in through Zoom if you want, and we'll sort of go through and just turn it into a bit of a social event. So that's going to be a lot of fun. And then it's a brand new year, and we'll be back in January with, again, Dome at Home programs and lots of live things. We have the Quadranted Meteor Shower on January 3rd and 4th. That'll be probably the first event of the year. And then we'll be doing our first and third Thursday of the month for Dome at Home. I'd love to know what topics you'd like to see. If you'd like to know more about telescope stuff, or if we want to bring Ulrika back for some more binocular challenge, yes. If you want to talk about whatever you want to learn about or talk about or share, if there's something that you want to talk about, great. Drop me a line and we'll schedule you in, and you can take on a segment or whatever. Or if you just have an idea for a topic, would love to put that in as well. Because otherwise, I just have to think about all the topics, and it's way easier if you do my work for me. Okay. Hollis has asked, can you tell us about the award I won? Yes. So there were a couple of awards that one was for Dome at Home, which was awarded by the Canadian Association of Science Centers. And we finally just got the award from that, sent from Toronto. I should have had a picture for you. I've totally forgot. But it basically gives it's a nice little glass plaque for best program from the Canadian Association of Science Centers. And then just a few days ago, the Association of Manitoba Museums awarded me the Award of Merit for the year for my work on Dome at Home. And it really is an easy job because there's this great community out there that has been with us. Some of you have been watching every single show since the beginning, which is what, a year and a half? Oh no, we're going to be 2 years old coming up in January. Wow, that's crazy. So, thank you to all of you for making this such a fun thing. And, we sort of thought, well, this will go for a few months in the pandemic and then everything will be back to normal, right? Well, back to normal took quite a long time. We're still not really there yet, but the planetarium has at least reopened. But we decided to just keep this going. And my number one argument was there's this community that we've built. We just cannot suddenly just pull the plug. So I'm really excited to be able to share all this kind of stuff with the bosses when they hear about, the people who are who are contributing to the show and who are going out and saying, oh, I saw this for the first time because you told me about it, that kind of stuff. It is a really great thing to be part of. So that's what we'll celebrate next week on our holiday show. Thank you to the folks that sent in images this time around. And you can always send us your images, drawings, anything that you've done astronomically, or if you have a story, if you've written an astronomy song, any of that kind of stuff. I mean, that's how we got our opening theme song from Sebastian and Genevieve. And so we're always open for all sorts of things. Thank you all. Have a wonderful evening. I'm actually going to stick my nose outside, and if it's not too cold, I'm going to try and at least get out there with the binoculars and just look around. I don't know that I have the energy to set up all the gear, but I want to get out under the stars. Thanks for inspiring me. We will see you on the 13th. It will be the next live broadcast. Thanks again. Have a wonderful evening. Good night.